Hello and welcome everyone to the Material Science and Engineering Info Session at the University of Washington. Thank you for taking the time out of your day, and we hope you'll be able to learn a lot from this session. My name is Karen Wetterhahn, and I am the Graduate Program Advisor for the department. Part of my role is to help you navigate through the admission process and all of the policies and procedures that come along the way while being a student. Some of that I will be reviewing with you today. A couple more people I'd like to introduce are people also on this slide, Dr. Christine Luscombe, who is the amazing interim chair of the department and professor, and she'll be speaking in just a bit about our department. I also wanted to introduce Dr. Eleutheria Romilli, assistant professor and lead coordinator for this session. She and I will be monitoring the chat throughout, and she'll be introducing the faculty spotlights a bit later. She'll also be introducing 3 of our students that we have available during our Q&A. And also she'll talk about her research during the faculty spotlights. And before we get underway, I wanted to show you our action-packed agenda. I also wanted to point out that we are recording this event. So it will be on the website later. You're welcome to not have your camera on and just use the chat feature. And please feel free to ask questions just throughout this session using the chat. And we may answer the questions as they come along, or we may just wait till the Q&A at the end. We also want to respect everyone's time. So we expect this session to last around 1 hour. But we will, we want to make sure we have enough time at the Q&A. So if anyone needs to leave right at 5, that's perfectly fine. So just real quick, you could see the agenda here. We'll be having Dr. Christine Luscombe speaking in just a bit, and then I will be going over the graduate program overview, admissions requirements. Then we'll be having our faculty spotlights, which will be really lovely, and we'll have Dr. Romilli introducing everyone, and she'll be able to talk about her research as well, and then the Q&A. So I will just go ahead and let our interim chair and professor, Dr. Christine Luscombe, take it from here.
Okay, great, Karen. Thank you so much for the introduction, and thank you very much to you all for joining us today. As Karen mentioned, please feel free to reach out to us anytime, even after this event, if you have any questions. So I'm here to give you an overview about our department in general. So we, in fact, are the oldest department on campus. We were founded in 1894. So in fact, just last year, we celebrated our 125th anniversary. We have a lot of award-winning faculty each year. A few of our faculty win awards in a number of areas that I'll introduce in a second. And one of the highlights that we have is that we really do serve as the core for materials research in general on campus. So because of that, we have a lot of interactions with the Clean Energy Institute, the eSciences Institute, the School of Medicine, amongst others. And the University of Washington is also very well known for being entrepreneurial. So within our department as well, annually, we have a lot of people applying for patents, and we have startup companies that have propped up through the research that has happened on campus. So next slide, please. So we really do focus on a large area of material science research in our campus. So we really do cover the whole gambit, but just listing a few of these, we have research related to biomaterials, biomimetics. We, of course, also have research related to specific materials classes. So we have ceramics research, composites research, as well as polymer research going on. And then we also, of course, focus on different properties related to those materials. So we have research ongoing related to electronic, optical, and magnetic materials. And we also cover the whole gambit in terms of materials chemistry, materials physics, materials characterization, and modeling as well. And I would like to refer you to our department website, because our website lists the different faculty members who are associated with the different areas of research as well. So next slide, please. Another thing that I really want to highlight is something that I've already referred to already, which is the fact that our department really serves as the core for material science research on campus. So because of that, we're affiliated with many research centers as well as research institutes on campus. So I'd like to highlight these collaborative initiatives that we have. So one such example of this is a Materials Research Science and Engineering Center called MSE, or Molecular Engineering Materials Center. This is a 6-year award of $15.6 million. And we have a number of MSE faculty who are core members of this center. And so you can see the names of these faculty members highlighted in red at the bottom. Next slide, please. Other things that I also want to highlight is the research that we do related to energy relevant areas. So just as an example, our faculty, Professor Jun Liu, he is leading a Battery 500 consortium, which is an even bigger award of $50 million affiliated with the Department of Energy. Next slide, please. And in addition to that, we also have DOE research centers called EFRCs. So we're associated with 2 of these on campus, Center for the Science of Synthesis Across Scales, as well as an initiative about quantum materials as well. So next slide, please. And now I want to turn my attention to various research institutes that we're also part of on campus. The first one here, it's known as the Molecular Engineering and Sciences Institute. And our faculty members have research labs within the institute, as well as doing research relevant to the institute. And next slide, please. You'll see that through this molecular engineering program that we have, we really do serve as the central core for material science research. So of course, we're affiliated to the College of Engineering through this initiative, but we also then end up collaborating with chemistry, physics, and biology in the College of Arts and Sciences. Through this, we also interact with the School of Medicine. And then finally, outside campus, there are several research institutes. For example, we have the Fred Hutch, Seattle Children's, and also the Institute of Systems Biology that we also work with through the molecular engineering program. Another institute that I want to highlight, which is a neighbor to molecular engineering, is the fact that we also have a Nano-Engineered Systems Institute. And through this initiative, we have 4 faculty members affiliated with this. And again, it gives us access to really state-of-the-art research space that available, not just within the University of Washington, but nationally as well. Next slide, please. I just want to highlight a couple of other research institutes, one of which I think is truly unique to the University of Washington, which is the fact that we have a Clean Energy Institute as well. And again, many of our faculty members are a part of this institute. So through this, this is actually a state-funded institute. We're very lucky to have a governor at the state of Washington who's very supportive of clean energy research. So we have this state-funded institute where we have really access, again, to state-of-the-art technologies. And then finally, another thing that I want to highlight is the fact that we really build upon our local strength in terms of companies that we are associated with. So we have joint projects with companies such as Boeing, Amazon, Toray, Intel, Colgate. I'll let you read the rest. But all of these, most of these companies have a local presence within Seattle. So this is, again, another highlight of our program that we offer here. And next slide. So finally, I just wanted to also give a big plug to the location. So we are based in Seattle. Seattle is an extremely diverse city. It's a big city, but we still have access to the local nature. So if you want to experience the big city life, you can do that. But also if you want to pursue a quieter life and go hiking and enjoy the outdoors, you can be in the outdoors within 30 minutes. So we have a lot of things to offer in terms of being able to provide a work-life balance during your time in graduate school. So at this stage, I'll turn back to Karen, who will be able to provide more specific details about our individual programs. So thank you.
Thank you. Great. So now I'm going to get into more of the nitty gritty of the master's and PhD program that we have to offer here. So yes, we currently have a total of 158 graduate students as of fall quarter. 97 are master's students, 61 PhD. We are really just always welcoming diversity. We like to showcase that we have pretty good percentage, 30% are female students, 43% international students, and 8% are the underrepresented minorities, which again, we're always looking to increase and doing as well as we can with that. We have 20 core faculty, 10 adjunct, and several affiliate and many collaborators across campus. So it's really great that we have someone for everyone. There's so many research area possibilities, a lot of elective courses. So there's just overall, we like to say the walls are just not very high between all of our College of Engineering different departments. So a lot of collaboration. And as far as elective courses, there's just a lot you have to choose from. We've been adding a lot of data science courses recently. A lot of students like to take entrepreneurship courses, just a lot of options there. So overall, this is a summary of the master's and the PhD program. The master's program is 36 credits. It's flexible, can be completed within 1 to 2 years. Option to apply to PhD in the future. There's some students do projects, some are able to find internships, and some do thesis options. You don't need to decide this right away. This could be something you would decide once you join the program. PhD, pretty standard 90 credits, and usually the degree is earned in about 5 years. 18 of those credits are going to be coursework. Actually, that's similar for the master's. And then there's the department seminar. A lot of the credits are going to be your thesis and dissertation-based credits and any additional coursework that your faculty advisor recommends. We have a lot of students on this call from outside of the UW. Thank you for being here. And just want to let you know, for those earning your master's, a lot of you would be able to transfer in 30 of those credits. That would be counted towards the overall 90 credits. I do want to point out, we still need you to take the course credits, but the 30 would factor into the overall 90. There's a lot of our students that start the master's and go into the PhD in the future. Generally, all of those credits can count towards all of your PhD credits. And that could be students that earn your master's degree in other parts of the UW as well, like mechanical engineering, for example. Chances are we'd be able to count all of those credits. You might just need to take a few of our additional core courses. And then we just wanted to point out, you can earn your master's degree along the way to your PhD. So we do have some outstanding students that start just come in from their bachelor's degree into the PhD program. That being said, PhD is definitely our most competitive program. The application deadline's coming up January 6th. GRE is not required, it is optional. So those who have taken it are welcome to submit your scores. It's not going to affect you either way. It might be looked at if there's just to give a better picture of your complete application if you do supply it. But again, perfectly fine if you don't submit GRE scores. The 3.7 GPA has been the average incoming GPA for our cohort within the last 5 years. That's been pretty consistent. Of course, it doesn't need to be that GPA, but just so you know, that has been the average. There will be a select group of our applicants that will be invited to our visit day. That will be in late February. It will be online. We normally fly people out to Seattle, but we will have a virtual event. And I will be getting in touch with those applicants sometime in late January to let you know. A lot of those admissions decisions will be based off of those that we invited to our visit day event. And then those applicants have until April 15th to make their decision. That's pretty standard across campuses, especially when funding is involved. That April 15th is going to be your deadline. So you have time to decide on the other offers as well. After April 15th, we may be able to make additional offers. So just in case you didn't get an offer yet, there's a chance there we might make a few more. Overall, as I mentioned, it's our most competitive program. We are usually admitting about 10% of our applicants. Like, for example, we get around 300 applications, have made offers to around 30. Incoming class size ends up being maybe 10 to 12 students, something like that. And then the offers also are providing RATA fellowships, and that's tied to the faculty advisor. So next I'm going to go into our master's program. The application deadline is March 15th. The applicants that were denied PhD, I'm going to be following up with those applicants and letting them know they can be considered for a master's program if they're interested. And so a lot of these students do end up applying to PhD in the future. You get a chance to really prove how well you are with your research and how you could do in classes. So a lot of our students that were denied the first time that joined the master's are able to join the PhD in the future. Not a guarantee, but absolutely. And it does increase your chances. It has been really helpful. And we do have you reapply for that. Average incoming for our cohorts have been around 3.4. GRE, again, not required, but optional. It's possible we might recommend it if your GPA is pretty low. So again, just to get a better picture of your complete application. Admissions decisions are sent pretty quickly. So in late March, we start sending those out. We're able to make offers to around 60% of our applicants just because we're able to have a bigger cohort. So I think our incoming class size might be around 70 for the 2021. So, but we are happy to be able to provide a lot more information about our master's program. We're going to do a follow-up info session on January 21st at 4 p.m. led by our director of the Applied Master's Program and professor, Dr. Dwayne Arola, who you'll be meeting later. He'll be one of our faculty spotlights, and I'll be hosting that as well. So we hope that you'll be there for that session, those of you interested in the master's program. The information to sign up is on our website. I'll follow up by email too with everyone who signed up for this event. So additional information, we have students coming from all different backgrounds in both our master's and PhD. So students that have had their bachelor's or master's ones entering the PhD from MSE, of course. Also chemistry, physics, other engineering degrees, other science degrees. So there's quite a range. I get the question a lot of, well, does that mean there's prerequisites? Usually not the case. But that could be on a case-by-case basis too, something we might recommend. What we do often recommend is we have a graduate tutorial in MSc class that that is required for all of our master's students, and then we recommend our PhD students take it if they might have had their background in chemistry, physics, or whatnot. So that might be the case. That is a two-part class offered in autumn and winter. More information you need to know than right now. And then just the general requirements, just bare minimum, 3.0, it's a cumulative GPA required to apply. That's pretty standard across all graduate programs at the UW. 3.5, of course, around that and above is always going to make you a more competitive applicant. For our international students or students that earn their bachelor's degree in a non-English speaking institution, we do require the TOEFL in that case. The TOEFL, we want that score to be at least a 92, and that's so you don't have to take any additional English classes once you're on campus. The TOEFL is waived. If you earned your master's or bachelor's degree in the US or an English taught institution where all of the courses were in English, and that's something you'll be entering in when you apply. Additional English tests may be required for TA appointments. We always like to point that out because if you, like, for example, on your TOEFL, if you didn't get at least a 26 on the speaking portion of your exam, then there's like we might require an interview or something like that. Again, a little bit more information than you need to know, but just it doesn't hurt having the heads up. So next slide, I am just going through the general summary of the application, pretty standard basic information. You're completing a graduate school application, which you'll be doing for every department you're interested in applying to at the UW. For our department, you just need to do one application if you're interested in both PhD and master's. But if you're interested in PhD, definitely do the PhD application. But if you're interested in both, you could just do the one. And it is an $85 application fee. You're uploading a lot of these basic information, resume, statement of purpose. There's additional personal statement that's optional. That's going to be if you have some additional information that's unique to you, maybe having to do with diversity or just some special something that you weren't able to capture in your statement of purpose. So again, this is just one and then 2 pages if you get that optional one on there too. Uploading unofficial transcripts, 3 letters of recommendation, which is all electronic. Additional statement, PhD. If you're applying for PhD, we do like you to state faculty you're interested in. That doesn't mean anything as far as tying you to a particular advisor. It's just good to know at that stage of the application. And then obviously TOEFL if required. And then couple items I definitely want to point out is applicants do not need to be making contact with faculty. You're not going to be applying directly to any faculty members, asking them, do you have a PhD position? No, that's not necessary at all. You're just going to be doing your application. And then we will be following up with you, if all goes well. And you can always reach out to me as well. And I think I said this before too, just everything's electronic. If you're admitted to the program at that time, we will be requesting additional information. So I think that's about it. And we could go through questions you have later. Next, just wanted to highlight that there's just so many networking opportunities throughout your time at the UW. We have our MSE Industry Day event every year in the fall. We have a lot of department seminars with industry speakers. There's the Career Center at Engineering. We have so many career fairs. There's just always some event going on. Even now, just lots of Zoom stuff, but just so many different ways to meet people from industry, meet other professors, meet people all over. And then we usually have barbecues right by our MSE location in the Mueller Courtyard, and we have our faculty and staff and everyone there. So just wanted to highlight a little bit of that. So I think that's good for now. And additional questions you have, please ask me in the chat, or you could turn your video on at the end of the session and we could go through those. Always able to email me, always able to set up an appointment. I've been doing tons of appointments over Zoom, which is really nice, just doing the one-on-one appointments that way. Eventually we'll be able to do those in the office, but at least right now, it's so great for people that are out of state that we were able to meet face-to-face over Zoom. So just wanted to point that out. So I think that's it for my slides. And now we're just going to go into the rest of the agenda. Able to get into the faculty spotlights, and I will let Professor Eleutheria Romilli take it from here.
Thank you, Karen, for the short and the presentation of the essential information. I think it captures all the basic stuff that people need to know on how to apply. But then again, whatever questions you have, we are checking the chat and we're going to be coming back to them at the end of the session of the Q&A, or always you can reach out to Karen if you have specific questions for your applications. So right now we wanted to give an opportunity to quite a few members of our department. Not all of them were actually able to be featured in this, but like at least a good representation. to hear from them what they are working on, what are the latest things that incoming PhD students will have an opportunity to start working on should they decide to join the teams of all of these PIs. And I would like to start with Professor Dwayne Arola.
Okay, great. Super. Do I have share screen capability?
You should.
Great. Yeah, I'm much better with a sharing screen than I am just talking out loud. So I had to fight in order to participate in this. And the reason I wanted to is to make sure that I could emphasize that there's a lot more going on in the department than just energy materials. My group works primarily on materials related to structural applications. And I would say we have emphasis in materials and engineering structures. I will say materials in medicine, and then materials in nature. My work, as I mentioned, involves structural applications, which is represented in all three of these areas. In this case, if you're in the Northwest or the Pacific Northwest, there's no way that you can get away from doing some research related to materials that go in the air or in aerospace. We're also involved in work associated with the durability of materials that are used undersea, for example, in the UWMC that's located in Bremerton. In the materials and medicine area, we're interested in both natural materials and the materials that replace them. And actually, one of the things that we're interested in is the material science of aging. That is what involves aging and the differences between your biological clock and the chronological clock, and how people have different rates of aging of hard tissues depending on the practice of life. In nature, we're interested in natural armors, which you see represented here, and also natural weapons. The importance of these materials is basically to give us inspiration for thinking about how to develop the next generation of advanced engineering materials. And so we find that there's a lot of interesting concepts here that can be applied in both of these particular areas. And so we're involved in various aspects of, the core of material science in all three of these major areas. A lot of our work in taking what we learn and trying to actually develop engineered structures involves additive manufacturing. And that's one of the primary ways that we're actually being able to realize some of those inspired microstructures. So we have efforts going on in polymers and polymer composites, in metals, as well as in ceramics. And you'll find at the University of Washington, across the campus, there's various resources that are available for additive manufacturing. I list some of the companies here that we have projects with regards to these particular material systems. And you'll see this is the area that we have the majority of actual industrial interactions. So this provides great opportunities for students. Rather than talk about the latest and greatest, what I thought I'd do is just give introduction to a quad chart, which shows an overview of some of the things involved in additive overall that were involved, from what might be called Q1, the feedstock that's used for actually the development of the engineered structure, to the post-processing, all the steps which contribute to the reliability of structures. For example, we have a project ongoing that involves powder reuse, its impact on chemistry, properties of developed structures, important for aerospace, development of new materials for aerospace, in this case, a continuous carbon fiber composite material. And then we have interest in the underwater applications, where it involves also 3D printing in this particular scenario, and then some of the important aspects involved in hydrophobics or hydrophobicity, and then also hydrodynamics. And we try to introduce a little bit of bioinspiration here. So I think that's all I have time for. I'll just say, if you have any questions, reach out to me. Thank you.
Thank you, Professor Arola. You're gonna make us all look bad because nobody else has slides, but
no, you don't know yet. You have lots of people. You don't know if they have slides yet. I can leave mine up there. I'll leave mine up there. You can just talk over them. How about that?
Maybe you can serve the whole department. Okay. That's good. Thank you very much, though. Then we can go to Professor Arthur Barnard. We're gonna do this alphabetically, so everybody gets it first.
I did have a slide just in case people started sharing stuff.
Oh, there you go. Yep, excellent. A for preparedness. Good.
All right. So my name is Arthur Barnard. I'm a joint appointment between the material science department and the physics department. That's something that's kind of nice about UW, is that there's a lot of connection between different departments like this. And my research is divided into two sort of topics. One is looking at thermal physics and quantum motion in nanoscale systems, particularly molecular strings, including carbon nanotubes and DNA molecules. And I also doing work on 2D materials in general and trying to understand how electrons interact with each other in unique ways and these quantum materials. A feature of my research is quite a lot to do with developing new techniques to probe phenomena at the nanoscale or at the low temperatures. So we do things like imaging the flow of electrons in a small 2D material device, or we use light to detect the vibrations of single molecules. And in doing so, we can understand something about how vibrations, phonons, or electrons talk to each other in an interesting way. Another project that we're just starting to get involved in is thinking about how do we take some of these interesting materials and manipulate them, for example, by shearing them and changing how the electrons talk to each other. And so that's just a little highlight of what we're doing. I think there's a pretty good thrust in the quantum material space in the department, and you'll hear more about that shortly. Thanks.
Thank you, Professor Bernard. Now we can go to our director of our graduate studies committee, Professor Guozhang Zhao.
Well, I don't have I did not prepare any slides for this presentation, but I just can simply tell you what I have been doing. Recently, our research actually is more or less focused on the sodium-ion battery, lithium-ion battery, and mostly on zinc-ion battery. So it is a little bit beyond what is currently commercialized the lithium-ion battery. We also worked on the solar cells, and we try to understand the fundamentals and try to improve the material properties and for the performance. And we don't know what in the future will be, because our research has been drifted from one area to another. And I think that's it. You can find more information by Google Scholar, see our recent publication. Thank you.
Thank you, Professor Zhao. And just to mention that Professor Zhao is one of our most cited and most influential research. He has been awarded many times, and this year included is one of the most cited researchers in the world, actually. So he's in the top list over there. So you can find a lot about his research on his website as well. And we can go to Professor Ting Chao now.
Hello, I do have a few slides to share. Let me share screen. Does it work?
Yes, we see your group.
Great. So basically, our group is doing material theory. This is a picture before the COVID lockdown, and we were fortunate enough to take a picture before the lockdown last year. And our group now consists of 9 members, so it's bigger than the picture showing here, with around 4 to 5 PhD, a few master students, and also on the Grad. So the methodology for our research is basically contains 3 essential components. So we basically use quantum theory. So as shown here is a Schrodinger equation. We also use high performance parallel computing, so which is an essential component. We use one of the most powerful supercomputers in the world to solve the problems relevant to the study of materials. And also, we also use the materials modeling tools to study the behavior of the materials built on top of the high performance supercomputing and quantum theory. So those are the questions that we try to address. So for example, we're working on energy materials relevant to the energy storage of the materials in terms of the solar energy harvesting and batteries. We also work on simulating the electronic property of materials, which can be potentially useful for designing new generation transistors and other nano quantum electronic devices. And those are some highlights of our recent research. And this picture is basically a spectroscopic simulation using our advanced modeling tools. This paper is recently published in Science. And we also have works which are being reviewed, focusing on quantum material design by designing a chemical reaction. And another focus of our group is basically the light matter interaction and excited states. If you would like to know more about our research, you can just Google my name and look at my Google Scholar page or our group website. And we basically prefer candidates with a strong physics or chemistry background. And if you have any further questions, you can contact me using this email, or you can talk to my students. Their email address are all listed in our group's website. I believe one of my graduate students is also going to be available to chat with you later during the student discussion session. Thank you.
Precisely. Thank you, Professor Chao. As Professor Chao just mentioned, in the end of this session, we're gonna have an opportunity to hear from 3 of our current PhD students. One is from his group, to hear a little bit about their experience being a PhD student in our department. Before we get there though, let's go to Professor Matthew Jankowicz.
Sorry, I had to unmute. Everyone, thanks for joining us remotely. I also have some emergency slides prepared, even though I didn't know that we were going to do that, but hopefully you can see my screen now. I am an assistant professor, like Arthur, with a joint appointment both in MSE and physics. And also like Arthur, my group works on two-dimensional van der Waals materials. So as you may or may not know, there's a pretty wide family now of materials that you can actually isolate down to the two-dimensional or a single layer limit simply by using Scotch tape. And these actually have a pretty wide range of properties. Electronically, basically anything we know how to do in 3 dimensions, we now have a monolayer counterpart. So the most famous one of these is graphene. It behaves like a semi-metal. And we also have insulators and semiconductors, and then even more exotic materials, many of which are actually discovered by some of my colleagues here at UW. So magnets in 2 dimensions, superconductors in 2 dimensions, and even more exotic materials that have properties of something called topology. So the name of the game in my group is basically taking these materials and stacking them back up into nanoscale sandwiches. And by doing this, we can take the properties of these individual materials and then create something that's actually more than the whole. You know, by stacking, we get a material that has properties that are completely distinct from any of its parent materials or any of its constituents. And then we can play other games. You know, we can twist these crystals on top of each other. And this can create something called a moire pattern, which can further modify the properties of these materials in controllable ways. And we actually have ways to do this dynamically, where we can use an atomic force microscope tip to twist one crystal on top of another while we're measuring the electronic properties. And then finally, I've also been developing techniques by which we can modify the properties of these materials by squeezing them with pressure. So we push the materials together and we can further modify their properties. And if we combine all of these, just as one example of something I've been working on recently, there's a growing field of something called twisted bilayer graphene and similar materials, where we can actually take 2 metallic sheets of graphene, stack and twist them at just the right angle, and get a whole zoo of exotic electronic properties out, which show both properties of strong correlations and non-trivial topology. So I think this is a really exciting field of research, and my group characterizes these materials both with low temperature and high magnetic field transport. So we run a current through the device and measure the resistance, and also structurally on the atomic scale using scanning tunneling microscopy. So we can actually image the atoms that make up these materials one by one. So that's all I have. Thank you.
Thank you, Professor Jankowicz. And now let's go to Professor Navid Sabiri.
Thank you. I didn't want to show slides, but Duane started this quite strongly, so I had to prepare some slides quickly as well.
Oh, I'll finish it with hopefully not disappointment. I'm not making any slides. Right. It's okay.
So just quick
Let's see them.
We are in our group, we are studying polymer-based materials, and basically the emphasis is on polymer composites. These are like carbon fiber, epoxy type composites that are used regularly in aerospace or automotive or sports industry. And the main focus of our research is on understanding how we have to make these materials such that the end part has the quality that we want. So the traditional thing in material science, the relationship between the process, microstructure, and then performance. But then with the emphasis that these things that we are trying to build are extremely large parts, like the wing of an aircraft, which could be up to 100 feet. This is a snapshot of my research group. In addition to traditional thing that we do on material science, that is understanding the material behavior, generating the next generation of this high performance materials, characterization methods. We do a lot now on class of machine learning method, which is called physics-informed machine learning. And these are machine learning methods that they can understand the physics of the problem, and they can guide engineers and scientists to either evolve, develop a new material, or control the processing methods. So some of the things we do with this method, I'll share with you. There was a couple of projects which we did with Boeing, for example, and we recently developed a software package, a machine learning software package, which was delivered to Boeing. Is going to be implemented in some of their fabrication lines. And these are machine learning methods that they understand how a material evolves, goes through different phase transition inside the really large processing environments. And not only that, they can in real time optimize all the parameters and work with them engineers based on the data provided to them to guide the processing. So it's a real-time optimization based on manufacturing data, which basically realize the Industry 4.0 dream of using this data for evolving new analysis methods. We kind of learned that we can apply the same method in many different directions. In some of our projects we do with Toray and with Boeing Company, we are developing this class of theory-guided machine learning models that can understand the physics of how cure kinetics occurs, how the thermochemical reaction occurs, how stresses are evolving, how failure occurs, and then guide the engineers and guide the researchers to basically develop the next generation of materials, or again, to optimize the material behavior. We even took this further recently in another collaboration with Boeing. We could train some neural network that they understand the theory, the fundamental theory of heat transfer. So this simulation that you see on the side is done by a neural network that understands if you heat up an object, how the heat is diffuses into it. And it can do that in real time without any analysis power. Anyway, so the focus is on the composites, but the main technology we are employing at the moment is on physics-informed machine learning. Thank you. If you have any questions, please visit my website. And my website is very simple to remember, composites.uw.edu.
Thank you, Professor Zabiri. So you can find information for the research of all of our faculty members on the department website. Obviously, I'll be the last one to go. I don't see that we have anybody else from our faculty members joining, so I will close this part of the session. So my group works with polymer nanocomposite materials. So those are materials that have a main phase that is polymeric and are reinforced from a second phase that has at least one dimension in the nanoscale. Some of our work has to do with biopolymer nanocomposite materials. So our main matrix is biologically derived. So we work a little bit with biofabrication. Especially we make materials out of plant, aqua and land plants, so plant cells and algae. Those materials that we make are performing mechanically similarly to plastics, but are entirely biodegradable. And they are made with low energy methods. We work a little bit on the biophysics side of it as well. Since we do work with living organisms, we study also the biophysics of plant cell growth and development. This is related to multi-scale mechanics experiments that we are performing in these living creatures. The other side of the lab is working with synthetic polymer nanocomposite materials. This is the fabrication methods that we're using extend from standard additive manufacturing, so 3D printing, all the way to nano 3D printing. So stereolithography methods that allow us to create structures that have features smaller than 1 micron. So these tiny nanostructures that we're able to make allow us to confine the nanoparticles that we use as additives in a very, very tiny volume. And this is when the physics starts becoming interesting, and interesting phenomena in terms of mechanics as well as thermal effects appear in that scale. So my group is using kind of the same tools to fabricate materials and to test them, but some of them are coming from a biological source, so completely renewable material fabrication, all to create sustainable and biodegradable materials, all the way to nanofabricated 3D architected structures that allow us to study nanoconfinement effects. I would welcome all of you to take a look in the department's website to find the links for everybody's groups, and then you can find their papers and all the exciting projects that they have been working on. And now I think we are ready to go to the next session, a part of the session that is the Q&A. Right before, maybe to get things going, I would like to welcome 3 of the current PhD students that we have in our department, 2 of which actually have transitioned from our master's program. So they started as applied master students, and then they applied to the PhD program and they got accepted. These 2 that I'm referring to are Mallory Parker, and you can find even her detail on the chat, her email on the chat. She is available to share her experience with you, should you want to hear more about it. And Kai Chen Si, I hope I didn't mispronounce horribly your name. So Mallory is a PhD student from Professor Arola, and she also works with me. And Kai Shin, she is a PhD student from Professor Ting Chao, also transitioned from the AMP program, the master's program, to the PhD. And we also have Yumping Huang from Professor Christine Luscombe's group. All of the students are current PhD students of our department. And I would like to maybe start from Mallory, and she can share with us a little bit about her experience. How is it to be a PhD student in our department, where she came from, and all sorts of stuff like that. And especially, Mallory, if you can also comment on the fact that you started from the master's and why did you decide to continue? It would be great. Thank you.
Good evening, everybody. So like Professor Romelli said, I'm Mallory. I'm newly in the PhD program, just got accepted this past summer. I have my bachelor's in material science from Georgia Institute of Technology. And I really chose UW. I went out for a visit in my last semester of college, and immediately just felt this great sense of community in the department. You know, all the professors really want you to succeed. And I find the coursework challenging, but really not overwhelming. You know, I've learned so much in the past year and a half that I've been at the University of Washington. This is behind me. This is actually our main vista. So that's Mount Rainier in the background. So it's absolutely beautiful campus. The master's program has been really good. Karen talked about the graduate course that is the 570, 571 series, which is the overarching materials course. And that was an incredible overview. Would highly recommend, even if you are a PhD student, you take it, because it is very helpful. You a lot of things can slip through the crack between PhD and undergraduate. So it's a great refresher regardless. But initially, I definitely did not see myself doing higher academia in a master's and a PhD program. After my undergrad, I just felt I wanted more hands-on research experience. So that's why I applied to the master's program, and then really found my home in Dr. Arola's laboratory. I currently work on advancing composite filaments for 3D printing, hopefully for a structural application in aerospace. And with both him and Professor Romelli, I've gotten my hands on all sorts of additive manufacturing, from 2-photon lithography to electron beam melting. So really cool applications. And I really hope to continue doing awesome work in my PhD program. But the transition was really smooth, and now I'm working on finishing my master's thesis so I can move forward in my PhD work. But my email is in the chat, so please feel free to reach out if you have any other questions.
Wonderful. Thank you so much, Mallory, for sharing your experience. And does anybody have any questions for Mallory because we have a few more minutes, so we can do a couple of questions and then we can move on to our next speaker. For Mallory, or for anyone, really. It doesn't have to be for that. If anybody has any questions, you're welcome to unmute yourself or write it. Yes, exactly. So I do see one question.
So I work with Professor Dwayne Arola. I got involved with a project with him through Toray Industries. So they're a huge composite manufacturer, both here across the world, really. They produce some really high quality carbon fibers and polymers. So I work with Dr. Dwayne Arola, and then Professor Romelli joined the UW back in January, and her work immediately with the biopolymers kind of clicked with me. So I started working with her as well. So proof that you can work with more than one advisor and really collaborate in nature. I think both Dr. Arola and Romelli are excited to work with each other even in some collaborations.
True.
I have a question.
Yes, please. Go ahead.
Yeah. Mallory, which route did you end up taking for your master's? Did you do the project, the internship, or the thesis?
So I chose to do the thesis. Initially going into the master's program, I thought the thesis would really make me stand out from other master's candidates. Now going into my PhD, I think it's a great practice for writing a larger dissertation. So I've definitely learned a lot from the thesis writing experience. And the thesis versus the project, really the thesis is just a little more involved, a couple more hours of credits, I believe, and the larger final document, the thesis versus just a paper.
Cool, thanks.
I also have a question.
Yes, go ahead, Parmis.
Awesome. So Mallory, did you feel like UW's like program was like a pretty good transition for you going from like undergrad to grad school?
Yeah, so my undergraduate was definitely very intensive. It was a very competitive environment. You know, I felt my undergrad set me up pretty well to succeed here at University of Washington. But I think the University of Washington, they, even if, you know, you're coming from all sorts of backgrounds, you know, they really do a good job of blending the coursework. So nothing, like I said, nothing is overwhelming, but it does challenge you. It makes you think, but all the professors are here to support you. So I had a very smooth transition. I had no problems. Tons of, you know, department events where you could mingle, pre-COVID times, of course. But it was, yeah, a great transition for me. And I went pretty much straight from my undergrad to graduate school.
Okay, cool.
You guys have the same alma mater.
Yeah, we were classmates. I just took 2 years off. So
exciting.
Good to see you again.
Yeah.
Anybody else? Maybe one more we can do, and then we can move on. If not, let's go to Kaishan.
Yeah.
Man, I'm so sorry. Maybe you can just say your name so we hear it nicely once.
Yeah. Hello, hi everyone. My name is Kaishan Xie. Yeah. So you pronounce exactly correctly. Yeah. So I'm a third year PhD in MSE department, and actually this is my 5th year staying in Seattle as I finished my master's degree also in MSE department here. And I come from China and finished my bachelor's degree back in China. And so as you can see, my background actually is the cherry blossom every spring in on campus, and it's really a great view. So if you choose here, I hope you will also enjoy the view. And yeah, so now for now I'm working with Professor Ting Cao, and as he introduced, our group actually is working on the quantum engineering and theory of low-dimensional materials. So my interest lies in the electronic, optical, and magnetic properties of low-dimensional materials, so such as the light-matter interactions and so on. So it's actually we are mostly a theoretical group, so I really enjoy to study the underlying theories for the properties, different properties and phenomena of different materials. So it's really interesting to learn those underlying theories. And as you may also interesting that I also transferring from master's program to PhD program in MSE department. Actually, my transformation is really smooth, and because I think for the core courses required for PhD programs, actually I already took most of them during my master's degree. So at the beginning, I don't need to worry about that the course load. So yeah, so I can focus more on my research. That's a great part. Yeah, of that. So I don't know what more are you interested in. So I'm glad to answer any questions if you have.
Thank you, Kaishan. And she also has shared her email. So in case anybody wants to reach out afterwards,
yeah,
they can. Can I ask what was your undergrad on?
I also finished. You mean the
your undergraduate degree in China? Was it in material science or?
Yeah, it's also
okay.
MSE.
Okay, that's good. Does anybody else have any questions? I don't know if we have actual international applicants right now with the time difference, but I think it would be helpful for them to see that you don't have to have a like international students are also able to join the program with no problem at all, especially now that we're doing our interviews fully online. It's not going to be a problem. Other years when we get the visits, it's not as fair because we may make offers to international students, but they don't get to visit, whereas the domestic ones do. But this year, everybody has an equal chance. Let's give a second now here in case we have any questions that have anybody has. I don't hear anything. If not, then we can go to Yunping Huang.
Yes.
Perfect.
Hi, I'm Yunping Huang. I'm a student from the LASCOM group. I'm from China, so I finished my undergrad and also master degree in China, also in MSE. And then I actually met Christine Lascombe, Professor Christine Lascombe at a conference. So back then I thought she was pretty cool and she is pretty cool. And then I joined her group for my PhD program. So in this PhD program, the work I'm doing is kind of innovative. We are inventing natural products. We are turning natural product into novel material that apply into really advanced optical and electronic application. So last year I did some work and I filed an international patent on using caffeine or theobromine, which is a abundant natural product from cacao beans and also coffee beans. And we turn them into highly fluorescent material, and then we apply into really advanced applications such as laser and also LED. And right now we are trying to use this kind of material into some biomedical application as well. And I want to add, I want to emphasize what Christine said in the beginning. Is like MSE is a center of the collaboration inside the university. So my project is actually associated with a lot of collaboration centers such as MSE and Clean Energy Institute and also Molecular Engineering Institute. And this is really helpful because this interdisciplinary experience is really helpful for accelerating your research because people have different skill set. And for me, I'm an organic chemist, so I would be really, I mean, it's not bad, it's just like not good at doing instrumentation. And in my project, I often paired up with some inorganic chemists, such as like in Professor Xu's group and also Professor Gamelin's group. And they have really advanced characterization technique that I can use that I'm not capable of using. So this would be a really 1+1 more than 2 situation. Yeah, and also there was a lot of social events in the department as well. So I actually met my business partner in the Foster School of Business, and we are starting up a startup to commercialize the technology I developed from cacao beans and also theobromine. Yeah.
This is wonderful to hear. Yunping, congratulations. I didn't know. I knew about your patent. I didn't know that you guys are going for the commercialization. This is great news.
Yeah.
I just wanted to point out one more thing, Karen, before we go to the rest of the Q&A, that for the collaborative environment and everything, you will have access to all of the centers, as we said before, and everything. That is not just place for you to conduct research and interface academically with other people. But all of those centers come also with activities that are for outreach as well as for your professional development. So when you are affiliated with an institute, they already are giving you opportunities to participate in outreach activities as well as participate in their established training networks for your professional development.
Yes, I think so. So the good thing about being in those centers is the first thing would be you have access to those research instruments, and then you can build a connection through the center because they have industrial collaboration as well. For example, in Clean Energy Institute, basically it's a kind of like a really big warehouse where a lot of startups are like resided inside the same building. So there would be a lot of conversation about how to spin our startup and how to deal with some kind of startup problem that we have. And this is really helpful.
And if I'm not mistaken, they even offer coursework that is related to that. I'm not sure in which institute, but they do.
I think so. I mean, actually, there is I know a student in MSE. He took something like a fellowship of stuff like that is like into the Foster School of Business. So he would take those business class as well, and that would be like the credit will be going into the curriculum as well.
Perfect. Sounds good. Karen, I'll let you take over.
Great. Thank you so much, everyone. So nice to have our students on this call too. Yeah, so I'll go ahead and start answering some of the questions that are coming through the chat. And again, you're welcome to turn your video on or just, unmute yourself and ask questions. Also recording this, so if you want to just, stay off video, that's perfectly fine too. But I'll go ahead and start answering these questions coming through. So one of them was about the visit days, and yes, so during the visit day, it is like the one.
Oops, we lost Karen. She will be able to log back. Maybe I can take the one question that has to do with the actual.
I am back.
Oh, you are back. Where are you?
I'm sorry. I don't know what happened, but I'm back. So very sorry about that. That was really odd. And for some reason, that's so sad. The chat disappeared, but I think I remember the questions. So I'll go through what I remember reading, and then you're welcome to add them back in. Sorry about that. So yeah, there's a question about interviews for the visit days. Yes, so visit days is when you'll be able to meet one-on-one with the faculty and be able to interview with them. And then the other question was, do all PhDs who get admitted, do they all get interviewed? And yeah, so the ones that don't make it to the visit days, I wouldn't say interview per se, but it is where, yes, there would be the faculty following up directly with the applicant and doing, phone or Zoom interview at that point. So let's see, let me see what other, I think all the questions might have come back in. That's a good thing.
I pasted them again. Let me read them to you. Is it hard to become a TA or RA? Are those options also open to master students?
That's a great question. And, no, we do reserve our TA appointments only for our PhD students, and same with the RA. So it is where our master students do come in with their own funding. We will get into more more talk about this at our master's program info session, just ways that's our incoming students are finding funding options. But yeah, the short answer is we don't have, general department funding available. That is reserved for the PhD students. And then let's see what we got.
Do many PhD students complete traineeships, such as the ACWED? I don't know what that is.
That one I didn't know. Maybe one of our students can answer. That was new to me about any traineeships or ACQUIT. I'm not familiar with that. Does anyone else, any of the faculty or students maybe know what that is or know about that?
It looks like we don't, but if this is an important question to you, go ahead and email it to Karen and then we'll have it answered. And then last one was, is it possible to work in the research areas, in a research area slightly different from what you're doing in your either master's or bachelor's? This one I can take because it has to do with the faculty advisors. Absolutely, yes. When we decide who is going to come to the PhD program and we interview you. Last year, for example, I work with polymers. I did interview people that did metals in their undergrads. That doesn't, in their undergrad or even masters. So that doesn't really, it's not really required that you already knew from when you were in your undergrad what you want to pursue for your PhD. It is helpful, of course, if it is if you have internships or work experience or undergraduate or master's experience in that topic, but it's definitely not like a requirement. Does anybody have any other questions?
Hey, Ali, can I add on a little bit to the traineeship question?
Yes.
So in the Clean Energy Institute, there's actually another traineeship that is not a grad. It's called Direct, and it's a data science traineeship that is open to MSE students to apply, both master and also PhD student.
Great. Yes.
Yeah. I was a part of that. I was a part of that program this year.
Wonderful.
Yeah.
Any other questions? Maybe from people that would be preparing applications? There is one coming in. Karen, do you want to take it?
Let's see.
Do you see the chat?
Yes. And open to. Oh, got it.
I have two different, but I think it often depends on who your advisor is. I know for one advisor, we meet once a week as a group, and then we meet as ever how often you need. For Professor Romelli, we meet as a big group, and then we meet in our smaller subgroups as well. So it really depends on who your advisor is, but they're all open to talk to you whenever, usually.
Yeah, for my group, there would be like one big group meeting every week, and then there will be also one-to-one with my professor every week. It's around like 15 minutes for those one-to-ones.
Yes, and those have to do with also the size of the group and the changes. We have professors here that they have 40 people in their group. So of course they cannot meet as frequently as other ones that have fewer members, but this varies greatly. And let's see another one from Diana. Do most people graduating from the UW with PhDs go into academia or industry or national labs? Great question. Karen, do we have statistics for that?
You know, it's a good variation. And even with our Career Center, I've heard them say there's a lot more going into industry these days. And what's really lovely is we have a general Career Center at the UW. We also have one that's specifically for the College of Engineering. So they're super helpful, you know, depending on what avenue you want to go in. So there is a choice, you know, so it is, I don't have the exact percentage, but just that there are lots of options.
We certainly have examples from all. And I would just like to stress here that we do have the Pacific Northwest National Laboratory, not just in the vicinity of the university, but also we have senior scientists from PNNL that are affiliated with our department, or even our faculty members of our department. So that can be also another vehicle to tap into at least PNNL, if not other national labs. And we have faculty members that used to work as postdocs in national labs before, or maybe PhD students as well. So certainly all of these avenues are open and available.
Yeah, and there's a question that I can answer, but I think that will be helpful because it is where someone was saying, well, what is it that the faculty really like to see in the statement of purposes? I mean, I always have the general information that we want to see your motivation for, what you want to do with graduate school, what you want to do in the future. It is great that if you did start researching different faculty and their, what they're doing and just what you can bring and, be, what your interests are, goals for the future. But yeah, I'll let one of the faculty members answer that question too, what they'd like to see.
Let me see if any other faculty members would like to chime in. I don't want to be the only one because I have only done that once, so it's not fair. Maybe somebody more experienced can say that they have seen many more incoming people. Do we have Professor Chow here? Who is our most old Professor Arola? If one of you would like to take that, what are we looking for in a graduate student application? Dr.
Please
Arola.
get off mute first.
I'm sorry, I was eavesdropping. I wasn't listening intently.
We would like you to describe to us what goes into a successful PhD application. What are you looking for, especially in the statement of purpose? What are you looking to see?
Well, first of all, that they can write legibly, right? Because getting a PhD involves a lot of writing. It involves a lot of presentation of results or findings and expressing the scientific content. So I think to me, I look for writing skills. So that means that will be beneficial. I can invest more effort with someone that writes well than I can with someone that doesn't. And then secondly, that their statement of purpose is clear, right? Not necessarily that they tell me there's no special words or there's no special direction, just simply that they're genuine, that they have a passion for something, and that it tells me that they're inquisitive and they would be the right kind of person to involve in my group. So that's a personal comment. That might not be true.
That's what we were looking for.
Yeah.
Because everybody has to remember that a person reviews the same material differently. You're looking backgrounds are different. We're trying to have multiple people. All your applications are going to be available to all faculty members. So it's not going to be that one person will review your application one time and they are going to decide if you get in or out. So I'd like to think that this gives a relatively fair shot, at least all the people that do end up making the application. Let's see about the GPA question, Karen.
Yeah, so is there a particular GPA cutoff where we would recommend the GRE? I would say, yeah, if the GPA is closer to 3.0 in particular, I mean, first of all, honestly, the PhD probably wouldn't be an option just from the get-go applying for it. That's possible in the future if you prove how well you are once you're a master's student and all that. But yeah, I would say it probably would be closer to around the 3.0 that and not necessary, you would just check with me. But then yeah, it's possible we would recommend the GRE in that case. Let's see, and both, and someone was asking for both master's and PhD. For PhD, this is our first year going through this, so not sure, but we are going to be, I mean, the goal is that we're going to be looking at, of course, the complete application, and so I wouldn't say there's any GPA in particular we would recommend at this point, or if you have a certain GPA to recommend the GRE right now. And then someone was asking about if it's permanently optional or only for 2021. Yeah, everything we're talking about is only for this coming year, but we just don't have that information yet. It's possible we might waive it in the future. We just don't know yet. We've talked about that. So we're just not sure yet. Someone did ask about if master students get interviewed. No, generally not. Generally not the case, no. But yeah, you're welcome to set up appointments. So of course, with me or anyone else. Let's see, have any of the PhD students who are here today TA'd for the department? If so, oh, okay. So any of the, yes, some of the students that are on the call, if you could talk about your TA experience, if so, what courses are generally taught by TAs? Oh, so many of our classes. Maybe if one of you want to just briefly answer that question.
Yeah, I've been TA for a lot of courses, but Actually, none of them are taught by TAs. I think all of them are taught by professors or lecturers. And actually, what TAs do is such as holding office hours, grading homeworks, or holding hands-on sessions. I think only for the lab course that TAs will teach for the most of the courses, but it's mainly for the hands-on session, I think. So all the lectures I think I experienced are all taught by the
Correct, and we do have some lab coursework for our undergraduate program, which many of our PhD students are TAing for. And all of them have, for example, that one is for materials characterization methods. I don't remember exactly the name of the course, but many of our PhD students are TAing for that.
Yeah.
And one more question from Kevin.
I can speak to this question. I chose the master's thesis option pretty much from the get-go, and I started talking to Dr. Arola right around the end of my first quarter. A lot of students will take their first quarter to see all the different professors and their options. And I believe in the 570 course this year, the professors would come in and discuss their research as to the class, and then you could set up a one-on-one appointment after. I would also recommend, I went to several professors and sat in on their meetings with the whole group. I did that for several different professors just to see what the vibe was like in the group. You know, you sometimes work with certain people who mesh better with your work style. And that's certainly true here in graduate school. So it was a good opportunity to see how the professor interacts with their students, what they expect from their students on a weekly basis. So that helped me make my decision on which advisor I chose.
And Karen, maybe you can say just a few words about the project that we have in the master's, even though we're going to do the separate session. But I think that's actually a good training time for people to see if they like working in a lab for their PhDs.
Oh, right. Just, yeah, that there's just so much variation. That would be something you would work out with your faculty advisor. And sometimes I always recommend the students be proactive too when they go to meet with the different faculty and say, here's what I'm interested in, here's what I see, you know, what I'd like to do. And then you would come to an agreement together. Professor Rowlett, do you have anything to add to that as far as?
With regards to projects?
Yeah.
I think that I can only say sky's the limit. The reason I say is because the projects, they are very diverse. They depend on what the faculty member is interested in. And a lot of times the projects actually are, I won't say co-developed, but at least they have the flavor of the student's interest as much as the faculty members. You know, we try to make sure that we're developing new understanding of materials to support a particular objective, but at the same time, the goal is for the student to gain new skills, right? And to be as engaged in the activities as the faculty member. And so that can only happen if the student is equally interested in what's going on, feels that the work is theirs, and not just the interest of the faculty member. So I would say that, you know, it's hard. I know from just being a program director and speaking to the various students in the department that the projects are very diverse, and that's what benefits the student if they do what Mallory mentioned, which is speak to a lot of different faculty members and find out what's really going on, right? What are they doing? What could be a potential topic that they might pursue?
I think I talked to at least three or four different professors in the department before I made an informed choice.
And she made a good one.
I made two good choices, actually.
Thank you. Thank you, Mallory. Okay, let's see if anybody else would like to add anything, also including our faculty members, if anybody would like to add anything that we maybe didn't touch on what is it like to be a PhD student in our department?
I actually have one more question about the master's program. you know, it's kind of talked about how it can range in length from 1 to 2 years. So I was curious, like, oh, is it the thesis one option that typically goes 2 years, probably, or is it like the internship one that usually lasts 1 year, or the project lasts 2 years, or is that kind of how it works, or is it more of a case by case basis?
Is this me?
Yes.
Okay.
I don't know. So yeah, I guess Karen, but I don't know.
I'll address it. So I would say it's really a case by case basis. A lot of times we have students that I will admit have told me that they didn't feel like they developed the level of understanding that they would like in just a year. Like they felt like the program went by so fast, and that there were a couple of courses they'd like to take, but their plates were full. So they decided that they wanted to stay an extra quarter or an extra 2 quarters. And honestly, in many cases, that benefits the student, because even if they did not or did engage in an internship, that extra quarter allows them to be able to apply for a position, and then use that experience of staying on and doing extra work to express to the recruiters exactly what they're doing and why. Because your strongest suit in order to be able to land a job, I think, is telling somebody why you're excited about a particular topic, right? And the first thing a recruiter is going to do is ask you questions about, well, what you're doing in the lab, and they're going to ask you a specific question about the uniqueness of maybe your project. And so showing them that is very helpful. And I think a lot of students learn that on the way when they're engaging in different interviews. I'm not trying to sell, people to stay longer. But certainly I can say that if you're going to write a thesis, that it generally would take more quarters than if you're just going to finish in a project.
Thanks.
Yeah, my pleasure. I got to go buy a Christmas tree, so I'm going to say goodbye.
Thank you. And we hope a lot of you will be on the info session masters thing. And
everyone.
Dr. Arola will be taking the lead on that one.
Yeah, great. Thank you very much. Goodbye, everybody.
Thank you.
Thank you for finding the time.
Yeah, thanks. Any other questions that have come up? Well, just want to point out, you're welcome to email me with anything else. As I mentioned, I'm happy to meet with you. You could just, do an appointment through the online schedule, and then we could do lots of Zoom in if that's something you want to do. Oh, there's one more question that came up.
Maybe that's the last one that we can take.
Sure. Interested in pursuing a professorship, are there opportunities outside of TAing to help with that process?
Well, I think that has to do really with the topic that you select for your PhD and your advisor. Advisors have a very close relationship with the people that are their students, and we work with everybody is working with you to enable you to reach your goals. So if we are talking about academic careers like a professorship, then there's really, that's actually people that are interested to become professors are the ones that know for sure that they want to go for a PhD. So they are already very clear on that from the beginning, but it's okay also to change your mind as you go. It's very human. But definitely there's a lot of outreach. There are teaching opportunities with the TAing, and your advisors are always working with you very closely to make sure that you are ready when your PhD or postdoc or whatever you're doing, we are studying with them, is done. They're making sure that you're ready for it. And it's not like you're just in somebody's lab doing your own thing, your own experiments, and in your own little corner. People are involved here, like you're a part of a team. So being part of a team means that we all work towards certain goals, and us as advisors, we're here to help you achieve a professional development that is of your own choice, not that one that we impose on you. That's the ideal case.
Thank you so much. That was really helpful.
No problem. Karen, I think since we don't have any more questions, maybe we can close off for now.
I think that's That's good. And gosh, thank you guys for being on this call. And we're really, and thank you, Dr. Romelli. Again, we're so happy that she decided to set this up in the first place, because we obviously have a need for this, and we plan on doing more of these in the future too. So.
Absolutely. And any questions that you guys have, especially regarding application process, we have Karen, who is the most informed person to help you in that, and not faculty members. We actually don't know very well the details that go on into how can you apply or anything, but we do review your applications and all as fair as we can. Thank you very much for joining, and we're looking forward to see your applications if you're interested to join our program.
Yes.
Thank you. Yes. Bye-bye, everyone.